Hello there, I'm Mr. Math Guy. Today we're going to be taking a look at a 10-minute video on differentiation rules, specifically the product rule, the quotient rule, and the extended power rule. The first rule we're going to look at is the product rule. The product rule and the quotient rule are more advanced rules than, say, the sum or the difference rule. Just a quick review from a different video. The sum rule stated something like this, that if we have a function f of x and it's equal to 3x squared plus 4x, then the derivative of this is simply just going to be the derivative of the first term, which would be 6x using the power rule, and then 4. So you take the derivative of the first, add to it the derivative of the second. Unfortunately, the product rule is not so simple, where you just take the derivative of the first and then you multiply it by the derivative of the second. It doesn't work that way. So let's take a look at what the product rule states. So if we have, if we're trying to find the derivative of function being multiplied together, so f of x, g of x, then it's not just the derivative of f of x multiplied by the derivative of g of x. That's not how easy it is. Now that is how easy it is for the sum and difference rule, but product rule and quotient rule, like we said before, are a little bit more advanced. So what we have here, this is equal to the derivative, or d over d of x, of f of x times g of x plus the derivative, d over d of x, of g of x times f of x. All right, so the product rule can be stated as the derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. Let's take a look at an example to see how this plays out. Let's say I have f of x is equal to 5x to the fourth times 5x. Well, the derivative of this would simply be the derivative of the first, using your power rule, would be 20x cubed times the second, 5x, plus the derivative of the second, so derivative of 5x is simply just 5, times the first. Now, doing a little bit of simplifying, this would give us 100x to the fourth plus 25x to the fourth. Or we can combine these and say this would be 125x to the fourth. Now, there's a simpler way of doing this one, but I just want you to see that the answer is 125x to the fourth. The simpler way of doing this one would just simply be, we can go ahead and multiply these together. 5x to the fourth times 5x is just simply 25x to the fifth. And then using our power rule, our constant multiple or power rule, we got 5 times 25 is 125, and then decrease that by 1 power, x to the fourth. So either way, we get the same thing. Now, using the product rule in this particular example might have been the longer way, but sometimes it's necessary to know, to be able to use it. All right, so this is the product rule. The derivative of the first times the second plus derivative of the second times the first. Now let's take a look at the quotient rule. The quotient rule is going to be the derivative of d over d of x of f of x divided by g of x. This one's a little bit more advanced. It is the derivative of the numerator, so derivative of f of x multiplied by the second, or by the denominator, g of x, minus the derivative of the denominator, g of x, times the numerator, f of x, all over the denominator squared. All right. So the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. That's the quotient rule. So looking at this particular problem, you couldn't simplify or cancel f of x equals 5x squared over all over 4x plus 3. So the quotient rule would be the derivative of the numerator, so that would be 10x, multiplied by the denominator, 4x plus 3, minus the derivative of the denominator, which is just 4, derivative of 4x is 4, derivative of 3, a constant is 0, times the numerator, 5x squared, all over the denominator squared, 4x plus 3, all of it squared. Now, doing a little simplifying in the numerator, you could distribute and get 40x squared plus 30x minus 20x squared all over this denominator. I'm just going to write d here. And then that is going to, you can subtract here, so you're going to get 20x squared, combining the x squared terms, plus the 30x all over this denominator of 4x plus 3 quantity squared. So there's how you do an example of the quotient rule. The third differentiation rule we want to take a look at is the extended power rule. And this is very, very similar to the power rule. And this time, though, we're going to have d over d of x of x with an exponent of k, where k is a negative integer. With the power rule, we just let it be c be a positive integer. This time, let it be a negative integer. But it's simply going to be the same thing. It's going to be k times n to the k minus 1 power. So to show you a quick example, if f of x is equal to x to the negative 4th, we would say the derivative of this is just simply negative 4, move that number to the coefficient, x, and decrease that by power to the negative 5th. Now, if you want to make that be a positive exponent, you could just simply write 4 over x to the 5th. But it's okay to leave a negative exponent in calculus. Let's look at this next example. This one you might think, oh, got to use the quotient rule, but not necessarily. You can change this function to look as 6 to the x to the negative 2 power. And this would actually be an easier way to do it than the quotient rule. So it's just going to be negative 12x to the negative 3rd power. Let's take a look at an example that might use a combination of these. I look at this problem, f of x equals 3x times 18x to the 4th plus 13 over x plus 1. First thing I want to do is, I want to say, you know what, I can distribute through, and this will be 54x to the 5th plus 39x over x plus 1. Let's distribute. That might help me out some. Now, to find the derivative of this, you're going to use the sum rule, power rule, quotient rule. So 54 times 5 is 270 x to the 4th plus, and you got to use the quotient rule. So derivative of the top is 39 times the denominator, x plus 1, minus derivative of the bottom times the numerator, all over the denominator squared. Now, this will simplify to give you just 39 over x plus 1 quantity squared. And so here is a combination of some of the rules. In a problem like this where f of x and g of x are both differentiable, and I'm trying to find the derivative of h of x, I'm simply just going to say, well, it's going to be, this is the constant rule, so it's 4 times the derivative of f of x. And then the quotient rule, So the derivative of f of, or g of numerator times the denominator minus the derivative of the denominator, which is 0 times g of x. So that's just going to be 0 all over the denominator squared. So this would give you 4 derivative of f of x plus 7 derivative of g of x all over 49. So just follow your rules. Sometimes you got to use combination of rules. The product, quotient, and extended power rule. These are some differentiable rules for calculus.